All right, guys, lesson 110. Today we're converting repeating decimals to fractions, and I'll say this is one of my favorite lessons. I'll also say that Khan Academy has a great video on this if what I'm about to show you doesn't register. But again, very cool lesson in my eyes. Just a heads up, I know that you guys have calculators, and those are going to be awesome for this lesson to check your answer. All right, but there's not going to be any way, so if you rely on your calculator going from decimal to fraction or fraction to decimal, you're going to be in trouble on this lesson because there isn't a good way for you to enter a repeating decimal into your calculator. So you need to know this method. You're going to be expected to know this method, and your calculator will be handy when it comes to checking your answer, okay? So in order to do this, there are 5 steps. I'm going to walk you through each step using an example of 0.3 repeating. So we are going to convert 0.3 repeating to a fraction. All right. So step 1 is to write an equation as x equals whatever repeating decimal you are converting. Okay, so let's go, I like this color. All right, so x equals, step 1, I'm just writing this as x equals 0.3 repeating. That's my first step. That's my first equation, and it's going to come in handy later in a couple steps. So that's step 1, right? X equals the decimal that you are converting to a fraction. Okay, step 2, you are going to count the number of unique repeating digits in the decimal you're converting. So again, we're doing 0.3 repeating. I have only one unique digit here that repeats. So be careful with this, right? 0.33 repeating and 0.333 repeating are both the same as 0.3 repeating. So I only have one digit that repeats, okay? So these are all the same, one digit. Here's an example of a repeating decimal that has 2 digits that are unique. 0.29 repeating, 0.292, 0.2929, right? These 3 are all the same, and they have 2 unique repeating digits. The 2 and the 9 are what repeat. So you gotta be careful with that. Don't just count the digits that are under the bar, because that's not gonna be your answer every time. If I did that, I'd have 3, but I know that 3 is not my answer here. I have one unique repeating digit. So I'm just gonna make note of that. One unique repeating digit, right? It's a 3, it's one unique, all right? So there's step 2. I'm just counting out how many there are that repeat. All right, step 3. I'm going to write a second equation using a power of 10 to the same number from step 2 and multiply both sides of equation number 1. All right, a lot going on here. So I'm writing a second equation using a power of 10 to the same number from step 2. So I know this is a 1, right? So I'm going to use 10 to the first power, which is really just 10, right? 10 to the first is 10, okay? So now I'm going to take my equation from step 1 and multiply both sides by that power of 10. All right, so here's my equation from step 1, if we remember. And now all I'm going to do is multiply both sides by that power of 10. All right, so in my second equation now is 10 times x, which is 10x, equals 10 times 0.3 repeating. So all I'm going to do is move the decimal, okay? So when I do that, I get 3 point, and this digit repeats, right? So after the decimal is just a bunch of 3's again. So I'll just put a 3 with a repeating bar. So there's my second equation. 10x equals 3.3 repeating, okay? That's my second equation. All right. So step 3 has us make a second equation where we multiply the first equation by a power of 10 to the same number from step 2. There we go. Step 4, subtract the first equation from the second equation. Okay, so here's my second equation. 10x equals 3.3. That's my second equation. And I'm subtracting my first equation from it. So minus my first equation, x equals 0.3 repeating. Be sure to line up the decimal points on the right side. So I got to make sure that those decimal points line up. All right, and I'm going to subtract. 10x minus x is 9x. 3.3 minus 0.3, okay? And down here I see, right, repeating digits should cancel. So the whole point of this is that when I'm done, my repeating digits should cancel out. So 0.3 repeating minus 0.3 repeating, they just drop out, right? So that's good. So I get 3 left over, right? 3 is what's left over. 3 point anything minus point anything, right? The point anythings drop out, and I'm left with 3, okay? That's step 4. So I'm left with 9x equals 3. Step 5, this probably should say, let's get fancy here. Oh, not that fancy. This probably should say, solve for x and then reduce, okay? So, I had, if we look back, right, 9x equals 3, okay? So 9x equals 3, solve for x. So what's happening to x? It's being multiplied by 9. I'm going to divide by both sides, all right? And I get x equals 3 over 9, and now I reduce. 3 over 9 is equal to 1/3. So 0.3 repeating in a fraction form is 1/3. All right. So I'm going to go back before I show you a couple more examples. Okay. So step 1, we write an equation with x equal to the repeating decimal that I'm converting. Step 2, I'm going to count how many repeating digits are there, unique repeating digits. In this case, there was just 1, the 3. Step 3, I'm writing a second equation using a power of 10 to the same number from step 2. So that's why we did step 2. My number from step 2 was 1, so I'm going to write 10 to the 1, which is really just 10. And then I'm going to use that number to multiply both sides of my first equation by that 10. So I get 10x equals 3.3 repeating. That's my second equation. Step 4, subtract the first equation from the second equation. My decimals I need to make sure my decimals line up on the right side. And if I did this right, my repeating digits should cancel. I get 9x equals 3. Solve for x, reduce. X equals 3 over 9. 3 over 9 reduced is 1/3. Okay? So, here's what I'm going to have you guys do. Here are 7 problems. Pause the video, do these, work through them. Again, use your calculator, but it's only going to help you really to check it, okay? Because it's no way to plug in 0.6 repeating into a calculator, okay? So try these, pause the video, give it a few minutes, give these a shot. Be careful with 6 and 7. They got a star on them. You got a percent here, okay? And so this is only for converting decimals to fractions. So you might have to do something there on those first. And this one, right, we probably know what the answer is to that, so it'll be a good one for you to work through and see and test the steps, okay? So pause it, give it a shot. All right, here we go. So I'm going to just show you a couple. I didn't do all of these with steps, but I will have the answers at the end for you guys that have paused the video and done it, okay? So here's the first one, right? 0.6 repeating. So I write my equations, x equals 0.6 repeating. It has 1 repeating digit, so that's going to be 10 to the first. Multiply my equation from step 1 by this power of 10, and I get 10x equals 6.6 repeating. So all I did was just move that decimal, right? Now I'm going to subtract my 2 equations, make sure my decimals line up. I get 10x minus x is 9x, 6.6 minus 0.6 is 6. And so then I just solve for x. X equals 6 over 9. X equals 2/3 when I reduce. So that's your answer to number 1. All right. I forget what number this was on the sheet, but 0.166 repeating. So you got to be careful with this one, okay? First equation, x equals 0.166 repeating. Easy. Number 2, step 2. How many digits repeat? Oh, I made a mistake here. Ended up working out all right, I think. I made a mistake. It's really just 1 digit repeating. So there you go. Okay, so let's fix that real quick. I think it still works, but let's check that. So this should be 1 digit repeats. All right, so it should be 10 to the first. Okay, so my second equation should be not this, but 10x equals 1.66 repeating. Okay, so I just multiplied by 10 that time. All right, and then I'm going to subtract, right? 10x equals 1.66 repeating minus x equals 0.166 repeating. All right, subtract, I'm going to get 9x over here, and I'm going to get, okay, so cancels, those cancel, I get 1.5. So x equals 1.5 over 9. And when I simplify that, I get 1/6. I'm going to just check, right? 1.5 divided by 9. So I can check it on my calculator by just doing this step, 1.5 divided by 9. Not sure if you guys can see that. And then I get this digit, this decimal, and I'm going to hit my fraction to decimal and get it to 1/6. Okay, so that'll give you your answer. So it ended up working out. Again, the reason for that being I did the same thing to both sides, so it worked out all right. Okay, next one. All right, 0.84 repeating. X, step 1, x equals 0.84. My 4 is the only digit repeating, so I have 1 digit here, 10 to the first. Multiply my first equation by 10. I get 10x equals 8.4. Subtract the 2 equations. 10x minus x is 9x. 8.4 repeating minus 0.84 repeating. I had to do some borrowing here. All right, the 4 repeatings cancel out. 14 minus 8 is 6. 7 minus 0 is 7. I get 9x equals 7.6. X equals 7.6 over 9. Again, I can plug that into my calculator, do 7.6 divided by 9. It's going to give you, if you did it right, a repeating decimal, and then you can hit the fraction to decimal symbol, and it'll convert it to its simplest form, 38 over 45. All right, I think I got one more for you. Okay, so these are the percentages. Again, I just had to convert these to decimals before I moved on, so I'm just going to divide both of them by 100, right? A percent symbol is just a divide by 100 in disguise. So this gets me 0.6 repeating, this gets me 0.15 repeating. We should know that, we did it already, it's 2/3. This one, x equals 0.15, 2 repeating digits, so it's going to be 10 to the second or 100. Multiply equation 1 on both sides by 100, I get 100x equals 15.15. Subtract the 2 equations, and I'm going to get 99x equals 15. X equals 15 over 99, reduces to 5 over 33. Okay, and here are the answers to all 7. We get 2/3, 1/6, 7/9, 7/11, 38 45ths, 2/3, and 5 33rds. So these will all be on, obviously, the video and on the notes online. Hopefully you guys did well on this portion. Great lesson again, Khan Academy. If you guys didn't like this video or if it went too fast for whatever reason, Khan Academy has a great lesson on this. All right, good luck, fellas.